Hey everyone, and welcome back to the channel. So, you've trained a fantastic machine learning model, and you're ready to unleash it into the real world. But hold on a second. Before you fully roll it out, how do you make sure it performs as expected and doesn't cause any unexpected hiccups? Today, we're diving into 4 key ways to test your ML models in production. This awesome infographic breaks down 4 crucial techniques you can use to rigorously test your models once they're live. We'll go through each one in plain English, so you can understand the pros and cons and decide which methods are best for your situation. Let's kick things off with a classic, A/B testing. You're probably familiar with this concept from marketing. In the context of ML models, it means running your legacy model, your current, established model, alongside a candidate model, the new one you want to test, for a segment of your users. As you can see here, a percentage of user requests, in this example, 90%, are still routed to the legacy model, while a smaller portion, 10%, are sent to the candidate model. You then compare the performance of both models on real-world data to see if the candidate model is indeed an improvement. Next up, we have canary testing. Think of it like sending a canary into a coal mine to check for dangerous conditions. With ML models, you release the candidate model to only a very small group of users. This allows you to monitor its performance and identify any potential issues in a controlled environment with minimal impact if something goes wrong. If the canary, your model, survives and performs well with this small group, you can gradually roll it out to more users. Now, let's look at interleaved testing. This method is particularly interesting for scenarios where users interact with a list of recommendations or predictions, like on an e-commerce website. Here, both the legacy model and the candidate model are used to generate predictions, and these predictions are then interleaved or mixed together in the results presented to the user, like Product A, Product B, Product C, Product D on Amazon.com. By tracking which results users interact with more, you can get a direct comparison of user preference between the two models in a live setting. Finally, we have shadow testing. This is a non-user-facing testing method. Here, all user requests are still served by the legacy model in production. However, the candidate model also receives the same requests in the background and generates its own predictions. These predictions from the candidate model are stored for later use and inspection. This allows you to evaluate the candidate model's performance on real-world data without any risk of impacting the actual user experience. You can then analyze these shadow predictions to identify potential issues or confirm the candidate model's superiority before you actually switch over. So, to quickly recap. A/B testing, compare the performance of two models on different user segments. Canary testing, roll out the new model to a tiny user group for initial risk assessment. Interleaved testing, mix predictions from both models and see which ones users prefer. Shadow testing, run the new model in the background without affecting users to analyze its predictions.